For generations, astronomers have searched the silent darkness of space, charting comets, asteroids, and drifting fragments that pass near our sun. Yet every once in a while, something appears that refuses to fit into any known category, an object that challenges every assumption about how the universe works. That's what happened with 3I, ATLAS, an interstellar wanderer racing through our solar system on a hyperbolic path, completely free from the sun's gravitational pull. It became the third confirmed interstellar object, following Oumuamua, 1I, 2017 U1, and 2I, Borisov, 2019. At first, scientists were simply fascinated by its unusual speed and angle of entry. But fascination quickly turned to disbelief. Because 3I, ATLAS didn't behave like a normal comet or asteroid. It appeared to be accompanied by massive, unidentified companions, large bodies moving in close coordination with the main nucleus. No one had seen anything like it before. The discovery triggered global attention. Was this a natural event, or something far stranger? Were these companions just fragments breaking away, or true co-travelers, possibly even structured satellites orbiting the main body? Observatories around the world focused their instruments toward this mysterious visitor. The Asteroid Terrestrial Impact Last Alert System, ATLAS, and its southern partner facilities began tracking every subtle motion. The data was baffling. These secondary objects weren't faint clouds or ice debris. They were solid, structured masses, each distinct in shape and movement. The mystery deepens. Some astronomers proposed that the nucleus was breaking apart as sunlight heated its surface, releasing massive chunks of rock and ice. Others suspected 3I, ATLAS might actually be a binary or multi-body system, two or more solid masses orbiting each other through interstellar space. If true, it would be the first time such a system has ever entered our solar system. A few daring researchers went further, wondering if these might be artificial constructs, dense, engineered formations that somehow endured an impossible journey across light years. While still speculative, even the fact that such a theory is being discussed shows just how unusual this object truly is. Estimates place the primary nucleus at over 5 kilometers wide, making it far larger than most known comets. Its high velocity confirms that it came from deep interstellar space, and it's moving far too fast to ever be captured by the sun's gravity. But the real puzzle lies in the companions. Could 3I, ATLAS have once been part of a planet-moon system, torn apart by tidal forces from its home star? Or perhaps it's the remains of a shattered world, cast adrift after some ancient catastrophe? A glimpse into another system. Spectral analysis of 3I, ATLAS has revealed something even more intriguing. Its composition doesn't quite match any known class of comets in our solar system. The ratio of gases, dust, and reflective materials hints at chemical fingerprints from another world, formed under very different cosmic conditions. If the companions share that same composition, they could tell a story billions of years old, a tale of planetary birth, destruction, and exile. But if their makeup is different, then we may be seeing pieces from multiple zones of an alien star system, preserved and carried through interstellar space. Such a system surviving the violent ejection from its original orbit, and traveling for eons through radiation and cosmic storms, would have to be incredibly ancient, and unbelievably stable. Now, as it passes through our solar system, humanity has a once-in-a-lifetime chance to study a visitor from beyond the stars, without leaving Earth. The companions and their implications. Since its discovery, observatories across Earth and in orbit, from ground telescopes to the Hubble and James Webb Space Telescope, have worked together to study this visitor. Every wavelength is being analyzed: visible light, infrared heat, ultraviolet glow. Each attempt aims to separate the main body from its mysterious companions. But this is no simple task. The secondary objects are dim and erratic, moving in ways that defy easy prediction. Distinguishing between real, gravitationally bound companions and optical illusions caused by dust or light scattering requires immense precision. Scientists are asking critical questions. Are these companions truly orbiting the main nucleus? Were they formed together, or torn apart during ejection? Do they share the same chemistry, or do they each carry different stories of origin? If these bodies differ in their elemental makeup, it could prove that 3I Atlas came from a system with multiple planetary zones, each contributing its own type of matter. Studying them could reveal how alien solar systems form, their structure, their chemistry, and their hidden histories. To the experts in planetary defense, the arrival of 3I Atlas serves as both a marvel and a warning. It proves that the universe is not a sealed system, but a cosmic ocean where interstellar objects can appear without warning. Visitors from the unknown that cross the boundaries between star systems like silent messengers from distant worlds. 3I Atlas poses no threat to Earth, but its complexity and scale are a stark reminder. Humanity has only a fragile understanding of what truly drifts in the interstellar dark. Out there, beyond the reach of our telescopes, countless other bodies may be moving, larger, stranger, and more unpredictable than anything we have yet recorded. But beyond the scientific concern lies something far deeper, a philosophical revelation. The passage of this object through our solar system is a reminder that we are not isolated in the vastness of space. Our sun, our planets, and every grain of dust orbiting within are part of a living galaxy, a network of stars constantly trading matter, energy, and history. Across millions of years, fragments of one world may be captured by another. The ashes of one sun may become the soil for another. The universe is not static, it is in constant dialogue with itself. And in this grand exchange, 3I Atlas may be one of the countless participants in the cosmic trade of creation. Some researchers believe these interstellar travelers may carry something even more precious than stone or ice, the ingredients of life. Organic molecules, amino acids, and carbon chains, embedded within frozen cores, drifting quietly between stars. Through a process known as panspermia, these objects could act as carriers of potential life, spreading biological seeds from one planetary cradle to another. If true, then every interstellar visitor is more than an astronomical event. It is a messenger of possibility, a fragment of an ancient chain linking every living world to a common cosmic ancestry. Perhaps life on Earth itself began this way, carried here by an object like 3I Atlas in the universe's earliest days. If so, then in studying it, we are not just looking outward, we are looking back toward the origins of our own existence. The legacy of 3I Atlas, expanded, from a practical standpoint, this discovery is already reshaping the future of exploration. Scientists and engineers are beginning to rethink what it means to encounter an interstellar object. Future probes and missions will no longer assume a single, simple nucleus. Instead, they must prepare for multi-body systems, clusters of debris, satellites, or companion fragments traveling together through deep space. Interstellar visitors may not be lone wanderers, but entire families of celestial bodies, bound together across unimaginable distances. Studying them could reveal how star systems evolve, how planets are born, and how material is exchanged between them. But beyond the data and the instruments, 3I Atlas is teaching us something profound about our place in the cosmos. It reminds us that the universe is not mechanical, it is alive with motion, rhythm, and interconnection. Every photon reflected from its surface, every spectral trace recorded by telescopes, adds another clue to an ever-growing cosmic puzzle. Its changing brightness, the strange shifts in its orbit, and the silent dance of its companions all hint at a truth that challenges our imagination. The so-called lonely travelers of interstellar space may not be lonely at all. They may be part of a greater, unseen network of celestial migrations, a continuous flow of matter and memory between the stars. To scientists, 3I Atlas is an unprecedented opportunity to test our theories. To humanity, it is a cosmic revelation, proof that the galaxy is filled with travelers, fragments, and echoes of forgotten worlds. Each carries a silent record of the star it once orbited, the collisions it survived, and the light it once reflected. Together, they form a vast library drifting through the void, a history of the Milky Way written not in words, but in motion and mineral and ice. As 3I Atlas moves beyond the reach of our instruments, disappearing once more into the endless dark, its story does not end. The questions it raised, about life, about interstellar connection, about the shared fabric of existence, will linger long after it's gone. It reminds us that in the infinite silence of space, nothing is truly alone. Every comet, every fragment, every beam of light is part of the same story, the story of a universe that is forever creating, exchanging, and remembering itself. And perhaps that is the greatest lesson of all. That we, too, are travelers, born from the same stardust that drifts between galaxies. We are the children of cosmic migration, briefly illuminated beneath another sun, before continuing our own journey through time and wonder. In 3I Atlas, we do not just see a visitor from afar. We see a reflection of ourselves.